and welcome to the first SUSS MicroTec webinar about inkjet solder mask technology. My name is Andre Bodegon. I'm the Managing Director of Adeon Technologies. We are the representatives of SUSS MicroTec in Europe for the solder mask inkjet technology. We're extremely pleased to be here and being part of this journey of SUSS MicroTec and the solder mask inkjet development over having been involved over 16, 17 years already. And it has been a very interesting journey with lots of ups and downs, but we are extremely pleased to say that really the technology has arrived. It's becoming part of our everyday PCB life and production. And therefore, we also have this webinar today to explain to you a little bit more about the technology, the partners that we work with, and also you will see a live presentation. During the session, there is a Q&A button in which you can ask questions already. We will try to treat all of them, or at least most of them, at the end of the session. So please do, we welcome you to ask the questions, write them down, and we'll try to pick them up. Now, before we move on, I will first like to introduce to you, to my left, Mrs. Marianne van Dam from Agfa, Mr. Ashley Steers from Electra Polymer, Mr. Luca Gautero from SUSS MicroTec, and the colleague that you will now start seeing live on camera are Mr. Peter de Vrieze, the sales manager for SUSS MicroTec, and our colleague Monier, who's going to run the system live for you during this webinar. So, Peter, over to you.
Well, thank you, Andre, for the introductions. And welcome everyone to our webinar. Welcome to our lab here in Eindhoven, where we do the samplings and development of the solder mask process. Today, I would do a small presentation on the workflow, which is used to go from a design to an actually printed circuit board, where you have solder masks printed on the locations where you actually want to print them. And I will show you in a small presentation which steps are used. So, in order to go from a design to an actual print, there are a few steps, and we've tried to make those steps very easy, especially for an operator who wants to start printing their boards with solder mask. I will elaborate on each of these steps. We have steps in the preparation and we have steps in the actual printing. So first, I'll start off with the first step, which is the PCB design, and which actions are needed to make sure that you can actually print your board. So first step would be to go and look at the CAD drawing that you have. When you have that CAD drawing, you need to have some design rule checks. And these checks are, first of all, to make sure that you have the minimum clearance. And if you don't have that, you have to make sure that you move your tracks or partially move the tracks so that you can actually print the solder mask on your boards. And in addition to that, you need to define the coordinate system. This is where you place the origin of your board in the left bottom corner of the PCB, and also keep your board in a portrait mode. From there, you need to define and check the fiducials that you have on your boards, because these will come in handy later on in the process. So once you have done that, you can take your design and take that into the flow engine. The flow engine, that's the next step of the process. The flow engine is actually a piece of software which we deliver along with the tool, and allows you to generate printing data out of your designs. It uses parameters which you have to add, like the board properties, the ink properties, the pretreatment, and together with those properties, it will create a work package of data that allows your printer to deposit the right material, at the right places on your board. And I'll elaborate a little bit more on that. So in essence, what it does, it takes the process development that we've done and adds it into this software so that as a user, you do not need to, say, develop this inkjet process for solder mask. It's already in the tool itself. It's in the software. So that actually means, oh, sorry, I'm going a little fast. That actually means that what you see on your design is what you get on your board. And that only works if you know how the ink reacts with your board. So if you know how the material flows out, if you know how the material stacks on top of each other, and how you can create printing recipes. So there's a few things that will need to be combined, and this is all done with the flow engine. So which parameters does it work with? First of all, the material. So on which type of material are you printing? Are you printing on copper or are you printing on laminate? Now, of course, the printing on one material or the other has an influence on how the material flows out. So it's important to know on which material you are printing on. Second of all is the pretreatment. There are different pretreatments out there, and each pretreatment has a certain reaction to the material that you print on top of your substrate or on your board. Yeah? So it is important to also add in that factor. The second or the third is the ink. There are different ink manufacturers out there. Today we are lucky enough to have a few of those ink suppliers also participating in this webinar. But they will also tell you that their material will also have a certain characteristic and will also have its own way of printing. Then once you know all this information, it's important to know the thickness of the copper on your boards, because that will also define how many layers you need to print on top of each other in order to build your structures on your board. Meaning that if you look at the image on the presentation, you see that we have different sizes of copper, and that means that when you are building ramps next to that copper, you need to make sure that you build enough ramps. So once you know all these things, then you can take it into the flow engine. And I'll zoom in a little bit. Oh, sorry. You'll see that there is an overview in which you can place certain information. Once you have your design, you can upload the design into the flow engine. And this design can be in different formats. It can be in UCAMX, can be ODB++, DABF, or Gerber files. And once you've done that in the flow engine, it gives you a small image of what you will be working on. Once you've done that, you see that there are a few parameters that you can fill in, like the board properties, the copper thickness, the ink properties, and the pretreatment. These are the factors that I just mentioned. And it will take those things into account. So if you're using, for instance, an AutoTech or a Mac Edge pretreatment, you fill that into the flow engine, and it will compensate for the outflow of the ink based on that pretreatment. Once you've filled in these properties, you can select the fiducials that you're using and also tell the tool in which way you should detect those fiducials. And then finally, you select your layers. So which one is the copper, which one is the solder mask, and which one is the drill layer, so that also the software can take that into account. Once you've done all this, you click the export button, and by clicking the export button, the software will create a work package for the printer. And this work package will create data where we can compensate for the drop size and the flow out of the material, and also calculate the amount of layers that we need to print. Because Inkjet is a digital technology, we have a lot of flexibility to add additional information to that work package, like identification or serialization. All of this can also be added through the flow engine. So that helps for traceability of the parts later in the process. So once we have this work package, we can export this work package and share it to either a network drive or share it to a printer where it can there be retrieved. On the flow engine, you can work with one flow engine for multiple printers, meaning that you can create these work packages and send it to different printers on your work floor. Once you have those work packages stored, you can retrieve them on your printer by using a barcode scanner or retrieving them through the HMI, which is on the printer itself. So we've prepared our work package. And once we have that work package, we can retrieve it and we can start a print. So today I will print on a JetX SM18. And the JetX SM18 is actually the printer that is standing next to me. The JetX SM18 is a solder mask printer that can accommodate boards up to a width of 18 inch. And it uses the Fujifilm Dymatics Samba printhead, which is a printhead that has over 2,000 nozzles, with each nozzle a droplet size of 2 picoliters. This particular machine has 6 of these printheads all in line, and has a UV bar before and after the array of printheads. The reason we have the UV lights before and after is because when we are printing, we can instantly also cure the ink when it hits the substrate and pin it down so that we can adjust the flow out of the material. We have the light on both sides so that we can also print in 2 directions. As mentioned, this tool has 6 printheads, and in order to print a board which is 18 inch, we need the amount of printheads that we have in this machine covers half of the board size. That means we print in 2 different passes, so we have to cover half and half. We also have a tool which is slightly bigger than this one. It's an SM24. That's a 24-inch wide tool. So there we can print boards from 24-inch wide up to 36-inch in length. That particular tool has either 8 heads or 16 heads. The 16 heads allows you to print a board using the full width of the print bar, and you can cover the entire width of your board. Today here we will print a board. We have it already lined up in our tool. The board itself has no solder mask on it. It only has the cover and it has the FR4. So we will be printing directly on the FR4 and the copper. The board has been pre-treated already, so you have to make sure about that it is in order. And in order to start printing, what we would do normally, either we go through the HMI and select the design that we want to print, or we use a barcode scanner to scan the work package and then retrieve the printing data so that it can start printing. Now, before we start the print, I would just slightly want to explain a little bit about the process of the print itself. First of all, before it will start printing, it will recognize the fiducials on the board. When it does that, we actually detect where the board is on our table, and if the board is aligned or if it's maybe even deformed. So in an ideal world, you would have a board which is perfectly flat, perfectly straight, and you have your design that you want to print right on top of that. However, if a board is not perfectly straight, and if it's slightly deformed, then you might have an issue when you start printing your design. So what we do before we start printing, we do an alignment and we scan the fiducials on the board. And if we then detect that there is an offset, we will match the image that we want to print to what our board actually looks like. So prior to printing, we will deform that image, making it fit to the board, and then we do the print. So that's what we also will show today. So in order to start our print, you retrieve the tool, the part, you press start, and then from there it will start doing the alignment. So as you can see here on the screen, it's searching for the fiducials. It's scanning every corner, and once it's done that, then it will calculate and see how the board has been deformed, how it is aligned, and after that, it will generate a new image that is fitting to the board, and then it will start to print. So as you can see now, it's starting. You see the lights flashing. You will not see a lot, especially not on the first layers. We print in several layers. To the trained eye, you can already see that there have been some changes to the board. And what we do now, we start off by printing the dams and the ramps, finer features of the board. And we do that in different steps. So depending on the thickness of the copper, depending on the pretreatment and the ink, the printer will determine how many ramps are needed. After you have printed the ramps, we will print the fill layers. So right now for this recipe, we will print 2 ramps and dams and 2 fill layers. So now it's printing the fill layers, as you can see. And as you can see, this is a very, very fast process. So now you see all the ink has been deposited in the places where we want it to. And in this recipe, we've also added a UV bump. So we're adding an additional layer of UV to pin down those droplets. And there is a slight delay on that because we want to make sure that the ink flows out a bit so that we get a nice shiny finish. So the finish of the board can be determined by changing the the recipe, changing the parameters. So we see the board now is finished. So in order to retrieve the board, my colleague Monier switched off the vacuum, and I can take the board out of the printer. So here you'll see we have our printed circuit board where we've added the solder mask onto the board. It looks very shiny. As you can see, we have deposited the material only where we needed it, and we've kept the areas that we want to keep free of solder mask exposed. So that really keeps the process very short, and it requires a lot less steps than a conventional way of adding solder mask. It looks very shiny. I can take this board out of the printer, and the ink is already cured. To make it, give it a final cure, the next step would be to place it into an oven. But that would be a next step. Yeah. So that is the printing of the solder mask with Inkjet. I hope this was very informative for you guys, and well, I also wish you guys a pleasant continuation of the webinar. And from here on, I would like to give the word back to our colleagues up top. Andre, take it away.
Really impressive, nice to see. It feels like I'm covering the World Cup of solder mask inkjet printing with all the cameras in a machine, in the laboratory, in a conference room. But now we are back in the conference room again, and I would like to further introduce further presenters of today. To start off, ladies first, with Mrs. Marianne van Dam from Agfa in Belgium. Short introduction to Marianne. She joined Agfa in 2016 and has the role of Senior Product Manager PCB Imaging Solutions. She has a MS degree in Chemical Engineering from the Catholic University in Leuven, Belgium. After several years as Research Associate at the Catholic University in Leuven and the California Institute of Technology, she chose a technical commercial career. She has a solid experience in a B2B environment and working for a big corporation, bigger corporate organizations, apologies, as well as smaller companies. She was active in business development, product management, key account, and international sales management. Marianne has always played a major role in solder mask inkjet development for many years, and it's fair to say that Marianne and Agfa have and still had and still have a huge contribution to penetrating this technology to become a real product in the PCB industry. So Marianne, the stage is yours.
Thank you, Andre, for the introduction, and many thanks to SUSS MicroTec for the invitation to participate to this webinar.
More than welcome to have you.
So I would like to start with just a short introduction of Agfa. So last year, after 9 months, we are a rather big company. We had 837 million euros of sales. As you can see, we have still quite some activities in the medical field with radiology solutions and healthcare IT. But important for today is our digital print and chemicals division. Within this division, we have still 2 subdivisions. We have our digital printing solutions. Here you can see we have wide format inkjet printers. We have the inks, we have the software, we have everything to offer the full solution to the graphic markets. We have been active in this application field for more than 20 years. Within the specialty films and chemicals division, you find our PCB materials, in which we have, of course, our inkjet products, which we will cover and talk more in detail about today. We have conductive materials for the printed electronics market. We have membranes for hydrogen separation. We have synthetic paper, and we have very big R&D division, which with really up-to-date equipment that we use for our own internal development work, but we offer it also to the outside world as a subcontractor. And we have film for non-destructive testing. Now I want to go more into inkjet printing. So we have more than 20 years expertise in inkjet, starting from our graphics division. Inkjet equipment, inks, and everything for sign and display. From that experience, about 10 years ago, we decided to develop inkjet inks for the electronic print or PCB market, functional inks. We have really a big R&D department. We have a dedicated team doing development and for inkjet inks. And that team is supported by a bigger group of chemical researchers. We have, as you can see on the pictures, the state-of-the-art equipment, all the tools and processes to develop our high-performance ink solutions. We have more than 200 patent families on inkjet inks and represented more than 1,000 patents. For the ink preparation, we have, of course, our labs where all the development work is done. We have a pilot plant and we have our industrial scale facility. We have a capacity of 2 million liters inkjet ink per year. On the pictures in the middle, you see, for instance, that's a miller. That's where the pigment dispersion is made. This is needs quite some know-how because you need to make a dispersion in nanoparticles, and you need the special know-how to also make it stable with the right dispergators in the ink. So we have a lot of know-how on that. Today we have the full range for the PCB production. We have our Legend inks. That's the first products we had for PCB and which really introduced inkjet into the PCB market. We have white, yellow and black Legend ink for rigid boards, and we have a flexible white Legend ink. Then we have our SMG02, our diplomat solder mask, which we talk more about in the next slides. And we have also our edge resist. We have our first generation edge resist ER01, but we have a new one that is really in the last phase of development and will be commercial very soon. Our inkjet solder mask, Diplomat SMG02. This ink is commercially available since quite some time and already used by several producers in the market. It offers an excellent edge definition. You can use it with a wide choice of print heads. That has to do with the choice, with the viscosity of the ink. So it can work both on Konica Minolta 1024i M and S heads, the Konica Minolta 1800i head, as well as on the Fuji Samba head. It's quite a flexible ink, so it can be used for both rigid and flex applications. And it's validated by the printer integrators. Of course, it's compliant with the industry and environmental standards. So we comply with the IPC SM840 standard. We are UL 94 V0. It also complies with the more stringent requirements from the automotive industry, certainly on thermal properties, the E2000. It complies with REACH. It doesn't contain any SVHCs, surface components of high concern. It's RoHS and VOC compliant. The next slide is giving a few details on the different standards we have to comply with. It's not everything. I listed the important ones, but everything is available and listed in our technical data sheet, which can be downloaded from our website. So, but to go through the important ones, it's your UL V0. It complies with the solderability standard. Resistance to lead-free solder, the two IPC standards in compliance with that. Hydrolytic stability and aging. Thermal shock and storage. The -65 up to 125 degrees centigrade for 100 cycles is just IPC standard, but we can do the more stringent standards from the automotive industry. You can also put it a thermal storage for 2000 hours at 150 degrees without giving any cracks or adhesion issues. We tested all the surface finishes. It adheres very well. It doesn't give any cracks after tin immersion, ENIG, silver immersion, hot air leveling, OSP. It also complies with the outgassing law and with all the electrical tests. More details can be requested. We are happy to share this information with you. Today, I'd like to talk about the footprint of inkjet solder mask compared to traditional solder mask. As you can see from the flows, inkjet the first one and then the conventional solder mask, you see that inkjet is a lot shorter and you have much fewer steps. Because of that, the physical footprint of inkjet solder mask is much smaller. You don't have the full coating, you don't have the pre-drying. In case you were still using film, you don't have the film plotting, no exposure, no developing. But very important, even more important is the environmental footprint. You have less materials. You have no film consumption, no film developer or fixer, no ink waste because it's a fully additive process and it's more flexible. It's also more sustainable because it's solvent free. So less VOCs, so also less nuisance for the operators. Much less steps, so much less power consumption, much less water consumption. So in many areas, everywhere around the world, legislation is getting more strict for the use of chemicals, for waste of chemistry, for VOCs, for water consumption. So the expansion or building of a PCB plant is getting more and more difficult. Now with inkjet solder mask, it really gives you the possibility to grow your business without growing your footprint. And on the top, as a summary, you can see the savings with inkjet solder mask versus the traditional one. It goes much faster. You save about 50% process time. Very important for prototype shops, quick turnarounds. You save on personnel, about 50%, less steps, so less people needed. You have no peripherals, no films to be used. Less steps, so less power consumption. Also power getting more and more expensive these days, so it's a very important point. About 70% saving, we estimate. And you use less ink. It can be 50% or even less. It depends on how selective you will work. Now, inkjet solder mask has also technology advantages. It's very revolutionary. It's really fully additive and it's very full. You have a full flexibility. So as Peter already explained, you can print a QR code for serialization, for traceability. It's all possible with inkjet. It's 3D printing, so it allows you to deposit a variable thickness and coverage on a board. If you need in a certain area a resistance against electrical voltage breakdown, you can put a thicker layer there. If an area you don't want any solder mask, for instance, for high frequency 5G applications, you can do that. You don't put any solder mask. In preparation of the assembly phase, you can build 3D structures, for instance, walls for underfill. So it's all possible with inkjet solder mask. In case of boards with high copper, with the traditional solder mask, you sometimes need multiple passes through the full solder mask process. You need to go through it 2 times, sometimes even 3 times to get good enough coverage of the shoulder of the copper track. In case of inkjet solder mask, it goes in 1 time. You build the dams, to a certain height, to the height of the copper basically, and you do it in multiple passes. As you can see on the picture, you see the picture in blue. You see really the different layers. So it's much faster, much more efficient. And there are other benefits, like for instance, if you don't want any solder mask in certain vias, you just avoid to put ink there. When you have small dams, as also Peter was already referring to that, sometimes you can lose them because with traditional solder mask, in the development process, you get undercut. And you can, because of that, lose the solder dam. With inkjet, the dam has a different shape, like you see on the picture, and there is no development, so you don't lose the dam in that process. So as a conclusion and a summary, the breakthrough of inkjet is really happening. We see the new greenfield PCB plants are using and choosing inkjet solder mask. There are already quite some installations worldwide, more than 35 installations up and running. And OEMs have high interest and have started the validations. Agfa can be your partner for this emerging new technology. We have a worldwide presence. We have offices in the US, in Europe, and in most countries in Asia. We have a very strong network in PCB because we are already more than 50 years active in the PCB industry with our traditional Idealine PCB film. We have a very deep know-how in Inkjet, also from our experience in the graphics field. And we are fully equipped to support the transformation to digital production. We have in our labs the full PCB process. We can pre-treat boards. We can finish boards with immersion tin. We can print. We have inkjet printers. So we can fully support you with the benchmark and the evaluation. Of course, in collaboration with our partners, but we have everything also in our labs. So that was my short presentation. I thank you for your interest and attention. If you have any questions at all, there is quite some information on our website, but feel free to contact us by mail. We will be happy to answer your questions and send you more information.
Thank you very much, Marianne. Most impressive to see that all the assumptions from over the years have been converted into facts of the advantages that Inkjet can deliver, and really facts that have been proven and tested. As we know, also your close cooperation with SUSS in the developing of the inks and the machines, and basically effectively the process. So yeah, it's specialism at its best. And talking about specialism, I would then also like to introduce our next presenter, is Mr. Ashley Steers from Electra Polymers, also a active partner to SUSS MicroTec in developing the inkjet solder masks. Ashley has dedicated over 25 years as a sales managing positions in printed circuit board at Electra Polymers, who are a leading printing ink technology company. He started as a quality control technician in 1997 and moved through the roles in an internal and external technical support, showcasing adaptability. With a wealth of technical experience, Ashley transitioned to sales, where his role in internal and external technical support laid the perfect foundation for the seamless transition. It's safe to say that Ashley's wealth of technical expertise became a cornerstone of Electra's growth. In the late 2021, Ashley took on the role of global sales manager for printed circuit board products at Electra. And in this role, he's able to navigate the complexities of the PCB industry, helping to ensure that Electra Polymers remains at the forefront of innovation and customer satisfaction. So as from a personal note, I can also say that I'm pleased that I know Ashley for a long, long time, and we're all proud to have his presentation today as well, and in which he will share his expertise with you. So as proper Britons will then say, Ashley, break a leg.
Thank you, Andre, and thank you for the kind words. It's almost as if I wrote the bio myself.
Coincidence.
And thank you to SUSS for inviting us to the webinar, and of course, thank you to everybody for joining us. Just like to say good morning, good afternoon, good day, wherever you are. So the purpose of this presentation from Electra is to offer up some ideas on solder mask challenges and how solder masks can overcome those, and some of the unique selling points of inkjet solder mask, which could be portrayed to your end user. So just as a quick company snapshot, I'll give you an idea of Electra, where we are, what we do. I will also look to give you some information on our ElectraJet range, mostly the EMJ110, the inkjet manufacturing side and the expansion of Electra into inkjet and inkjet materials, and then I will move on to the main part of the presentation, which are the internal challenges, or how Electra see the internal challenges for the PCB manufacturer, and also some of the unique selling points of inkjet which can be portrayed to your OEMs or final user. So really, company snapshot. This is a slide really to show you the pedigree of Electra within the PCB industry. We have been involved in solder masks for more than 40 years, or for 40 years. We were established in 1984, We diversified over 20 years ago into wafer level packaging. This was seen as a complementary technology to our existing business, and now actually makes up about 50% of our global revenue. We are based in the UK, just 30 miles south of London, so very close to major airports and seaports. And as you would expect from a global spanning company, Electra has all the accreditations. Electra is already established as a technology leader in traditional solder mask, but we are also emerging as technology leader in inkjet solder mask. We have a wealth of experience. As I've already said, we've been in service to the PCB industry for 40 years, so we have all the experience from the traditional solder mask and all the know-how of the processes before and after. We commercialized our first inkjet solder mask more than 5 years ago, and we have been researching inkjet solder mask for more than 10 years. We've worked very closely with all pre-clean manufacturers and integrators, and also printhead manufacturers. So we are currently approved on and with the major printheads and tool manufacturers. We have a lot of customers currently using inkjet solder mask, some of which have already made the switch to 100% of inkjet solder mask, so removing their traditional process. The technology, as we see it, inkjet, is really works well with our current roadmap, being digital, it's additive, and it's sustainable. But importantly, it's been earmarked for a lot of growth. So we've managed to work with potential customers, volume installations in America and Asia. And I think I'm fairly safe in saying by the end of 2024, Electra will be the largest supplier of inkjet solder mask globally. So to meet that anticipated demand, Electra has invested heavily within the inkjet facilities, putting an additional facility on in the headquarters. And by the end of 2025, we will have high volume lines running up to 100,000 kilos per month of inkjet products. Additionally, alongside that, we also appreciate the need that we need to expand the infrastructure behind it. So we are investing in the laboratory, we're investing in people, and we're investing in equipment. So by the end of 2024, we hope to have, or will be commissioned, the new laboratory expansion as well to go along with the manufacturing expansion. So really coming on to the main part of the presentation, to sort of identify some of the internal challenges of PCB manufacturer as we see them within mostly the solder mask area or the solder mask sphere, but some of these can relate to other aspects also. One big factor we've seen post-COVID is personnel. Finding new people, and more importantly, keeping new people is becoming more problematic. There's a number of areas that we see with this. Some are generational, also the work environment, manufacturing environment, the sort of specialist skill set around solder mask and solder mask application, and just the sheer number of staffing needed for the department. Inkjet has an important role to help negate some of these. Inkjet is a digital process, front-end driven, so it's more appealing to the younger generation who have grown up with technology, are more used to technology and screen-facing type systems, not so much the hands-on manufacturing side. From the environment aspect, in regards to the manufacturing side, the solder mask department can be a bit smelly. It's handling chemicals, solvents, masks, and it can be a sort of a different type of environment that maybe some people are used to who haven't been in manufacturing. So Inkjet, as we've seen from Peter's presentation, has or is a clean environment. It's boxed in, it has extraction and filtering, so your limited smell, limited exposure to chemistry. It's a hands-off clean process will make it more appealing to potential staff. Then we come on to the skill set side. A lot of solder mask applications need a certain sort of art or magician from the screen printing trade or a spray trade, where the art or the process of screening is actually almost a dying art these days. So Inkjet actually comes in and de-skills the operation because it's front-end driven. It opens up the opportunities of staffing to a wider audience and a younger audience, which could also make succession planning easier for the future. And then you just have staffing numbers. As we've seen from previous presentations, the process steps are a lot less with Inkjet. There's more scope to automate. So therefore, less people means less recruiting, less training, less potential problems with new staff. And all of this really culminates to the fact that you can reduce costs, because all of these things involve cost. Also something that is seen and is a risk is defects. So causing scrap, remakes, all of these things cost money. You have FOD, foreign object and damage, ink in holes, ink on pads, ink where you just generally don't require it or don't want it, or missing dams or missing features, or expanded dams, expanded features. So how does Inkjet help with this? Well, Inkjet is within an enclosed filtered coating environment. It's pin cured before it leaves that environment, so it's not wet or sticky. So when it then comes out into the department, into the solder mask department environment, which may be unfiltered or maybe sort of not exactly a clean room, means that you won't get the foreign objects sticking or placing on the solder resistor. And it also doesn't have to go into a tack dry oven where you're circulating air around, which obviously when you've got wet ink or sticky ink could cause an issue. And sort of covered also previously, it's an additive digital process, so the ink is only applied in areas where it's required. So if the data is correct, then the mask will be deposited where you need it, not in a hole, not in a pad, on a pad. Inkjet is a additive process, as I've already said. So it's very different to traditional methods of coating. So there's no overdeveloping, underdeveloping, over drying, under drying, overexposure, or underexposure, removing features, removing pads. So it's a very neat system to move forward with. Environment regulation, as we all know, these restraints are becoming tighter and tighter. As Mariano correctly pointed out, it's very important moving forward. Restrictions on water, even just in some countries, the water restrictions of getting water in, taking water out. VOCs is becoming a bigger issue. Energy constraints, cost of energy, or even availability of energy. These are all relevant to PCB manufacturers today. And as you can see from the table, the Inkjet solder mask compared to traditional solder mask, there's a big difference in environmental aspects, less water, less power, less VOCs. Regulation, there's new regulation coming out, it seems every day, every month, every year, and it's changing on a regular basis. I can say that EMJ 110, Electra's Inkjet solder mask, has 0 SVHCs and complies with other related regulations. I'm not saying that the Inkjet solder mask won't actually be covered by new regulations or changes in regulations. It will be it will be tied to that also, but it just should be the way we formulate the products can mean that we can sort of formulate out some of the products which are SVHCs. So hopefully now I've sold you on Inkjet itself and the process and all the positives. How does that translate? How do you move that on to your customer, the OEM, the CEM, the final user? So got some points, unique selling points, potentially some upsells that you would be able to use once you adopt the technology. So meeting industry requirements, okay, not necessarily an upsell or unique selling point, but meeting all of those requirements such as SM840, thermal shock, storage, it should be a reassurance to your customer, the end user, that the product is fit for purpose. I've covered also it's an additive process, so reducing defects such as ink on pads, ink in holes, missing features is now also not necessarily an issue with Inkjet. And repeatability is an automated front-end driven process. Therefore, there's limited human interaction and human factor, which means that you should be able to control the process better, and it's reduced process. You won't have humans interfering with the process, changing parameters or leaving things in processes for too long. Again, not necessarily something you want to communicate to your final user, but the fact that you have less process, more repeatability, less chances of error should be a selling point. Flexibility, I don't necessarily mean flexibility of the mask, but flexibility of the process. Inkjet really has this is where Inkjet really excels as a unique, with its unique selling points. You can jet more mask in one area, less mask in another area, put mask on a copper track where it's needed for reliability testing, or just not put any ink on the laminate or limited amount of ink on the laminate, or you can build 3D structures, walls, dams, barriers to help with underfill, solder paste placement. These really are unique to Inkjet, and your competitors who don't have Inkjet will not be able to offer this to the OEM or the final user. Sustainability is clear. All organizations, big, small, medium-sized companies, all need to show that they are on the sustainability path and show their green credentials. And Inkjet is certainly a way that you can cut down on these things. Industry 4.0 is something that is very important. You have possibility of automation, you have more data, because it's data-driven, connectivity, traceability, which is very important. Also, you're going to have analytics, AI. All of these things can be used to continuously improve your process and can be sold to your customer as a real advantage of the process. So in summary, Inkjet, I think, as we've all said, is now here. It's arrived. It's not coming. It's here. 2023 was a big year for Inkjet solder mask. There was a number of placements. 2024, I think, will be an even bigger year. There are multiple placements of tools this year, from small volume, medium volume, large volume. So it will be proven across the spectrum. Inkjet solder mask simply simplifies the process. It's a simpler process, maybe not simple, as I'm sure Luca would agree, but it helps simplify the process in regards to less processes and it not being such a skill in regards to screening or spraying. So it's a simpler process. It's additive, as I've explained a number of times. Risks of defects and all the things which are attributed to that will be a real benefit, not just to the PCB manufacturer, but also the end user. Environmental sustainability, that's obvious. Inkjet solder mask is greener. And then a big part of everything in life these days, time, and we all know time is money. So cost savings are prevalent across Inkjet and the Inkjet technology. Thank you very much for your time and listening to me. I'm more than happy to answer any questions. I do have a question for you guys. Inkjet is here, it's ready. So I want to know what you guys are waiting for. Thank you.
Thank you very much, Ashley. Very interesting to see that besides from both of you, the technology aspects of Inkjet have also now so many proven aspects of the elimination of human error, of cost saving in personnel, but also with the upcoming and ever-changing regulations for which Inkjet is apparently already prepared. You call it simple, but actually, me as an old machine manufacturer, I think that when these things are simple, there is a reason for it, and it's been simplified, I guess, also by SUSS. By means and of their development, and this is one of the reasons I believe they've won the Innovation Award at the Productronica as well, because when you innovate to the level that SUSS has done with their machine, then you win these awards and you make it simple. So thank you very much. And yeah, oh yeah, well, there is a coincidence that thing is there. I definitely did not see that, but yes, it is the award. And that actually leaves us to the last presenter of the day, coming from the horse's mouth, Mr. Luca Gaudero, the product manager of SUSS MicroTec here in Eindhoven, the Netherlands. So short introduction to Luca. He's been has more than a decade of experience in additive manufacturing of microelectronics for renewable energy and semiconductors as an innovation leader, both academically and professionally. This has resulted in several patents that he holds, publications and conference presentations. He obtained a PhD in energy-related disciplines from EPFL in 2010 and an executive master in energy management from ESCP in 2015. And also for Luca, on a personal note for me, me as Adeon as SUSS business partner in Europe, I can say that working with Luca is a real pleasure. He leaves no stone unturned in supporting the implementation of solder mask inkjet technology into our PCB industry. So, Luca, the stage is yours.
Thank you, Andre, for the kind words. I will take the task to summarize and conclude this webinar. So, my colleague Peter showed you how we simplified in just 3 steps. I want to add a few details and also to follow upon some of the information we have heard today. So, yeah, as a PCB manufacturer, first step is to create and prepare the design in a preparation stage. Within the offer of SUSS, we provide a flow engine, this software that helps you to define fiducials, set the ink, the board details, and the pre-treatment that are set for your manufacturing. All of this information goes into the flow engine, as Peter explained, and the heavy work is done by the algorithm and the database information inside the software. So what we're talking about is an automated compensation of a droplet size and the flow out, and the creation of the different layers and the stacking of the different layers in order to achieve fine features, as well to get to the right solder mask thickness for the copper intended. So once this is all put together in a work package, this is made available to the production site. Of course, is linked with a name. As Peter showed, it can be the operator typing it in, or it could be a barcode reader retrieving it from a batch protocol or from the board itself. And this will allow the print. And the print will be just as simple as loading the product and pressing start. What happens inside there is product recognition, fiducial registration for deformation, as it was very well explained by Peter with the sketch. That will then therefore go to rasterization, which makes full use of a high resolution of the SUSS equipment, and then it will result in the print. So yeah, it is as simple as 1, 2, 3, as we see there. Yes, SUSS made effort to automate as much as possible the specialty of inkjet and to digitalize it, so that it's easy to follow it, to enable data, to use serialization on the board, and therefore to enable improvements on the go. So this terminates our webinar. We have quite a bit of time for questions.
Yes, well, thank you, Luca. There several questions actually came in. Just picked them up from the table. So I have a question here from Mariana. What do you see as further challenges in the development of the inkjet solder masks compared to conventional inks?
Well, conventional inks are in general, they are very different from inkjet inks. They are most of the time two-component inks. So they start to react when you bring the components together. In case of inkjet, it's one component. So it's quite difficult to develop a stable ink that has a shelf life that is long enough, because everything is in one component. In addition, inkjet inks, they are shedded through the print heads with nozzles with very, very fine droplets. So the inkjet inks are composed of nanoparticles. So that also limits the formulation. For instance, traditional inks, you use certain components like fillers to reach certain properties. That's not possible with inkjet inks. The pigment dispersion, for instance, has to be in nanoparticle size. So also that requires a very special know-how to do that, and to have it, the right dispergators to have it stable in the ink. Also here, it's much more narrow window to develop the right pigment dispersion. It's very low viscous inks compared to traditional inks. Also there, you are more limited in the formulation. So inkjet inks are in the end very different from traditional inks.
Yes, yeah, okay. And what in relation to that, what determines the etch definition or the line quality in the inkjet process?
Here are different. Here you have to consider different factors. So what is important is, of course, the ink. The ink has to be good. It has to have the right surface tension. It has to jet right, no satellites. So yeah, that's very important. But it's not only the ink. With a good ink, you can have bad results. You need to have a very good surface pretreatment. Mm-hmm. The best surface pretreatment for inkjet is the chemical pretreatment. But it's not just the micro etch. In traditional solder mask, a micro etch is fine, but because the viscosity of inkjet inks is so low, if you have just a micro etch, the ink will flow into the narrow pores. So you need an anti-bleed step after the micro etch, and that gives really the best etch definition. Mechanical pretreatments also work, but they don't give the same etch definition. So really recommendation, chemical pretreatment, but etch combination with anti-bleed.
Yeah.
And then of course, the ink, the pretreatment, the machine is very important, the tool, both from the hardware and the software side. So Luca can explain this better, but yeah, you need a high precision tool to get a nice resolution. It needs to be a solid machine. What is important, the movement of the shuttle, the distance between the print head and the substrate. So all these things are very important. But also the software side, it's the waveform for jetting the ink that is important, but also the print strategy. So there is a lot involved to get it right. It's not just one component, so we really have to look at the full picture.
Well, as a totally objective sales guy, I would say you've come to the right place if you look at the sign behind you. I think, but seriously, there's a lot of work that has gone into the tool. I've got a question for Ashley, because there was talks already about flexible inks.
Yep.
You also have a range of inks available for the flexible circuit,
Yeah, I mean
or one ink? Or...
Yeah, the quick answer is yes, we do. It's available in multiple colours, so green, as you would expect, but also an amber or orange colour, which would meet or look very similar to Kapton. The flexibility is very good, sort of dynamic flex. It will pass 3mm mandrel, as well as all the other aspects of solder mask requirements it meets. It looks to be a very dynamic product, actually.
Yeah, and we're seeing also various questions coming in about the cost. If you compare the cost of inkjet printing against traditional conventional printing.
Yeah, well, as you can imagine, this is a question that is asked a lot.
I see the screen sort of exploding. Yes.
How does it stack up? I think as was alluded to in the bio, I started back in '97, and around that time we were selling traditional solder masks for 5x what we're selling solder masks now. So with all new technologies, as LPI was back in them days, or if you just look back to direct imaging masks, the price was more expensive to start with. But that isn't really the full picture. As I'm sure the PCB manufacturers would have seen, actually the cost of traditional masks is increasing.
Yes.
It became mature, and now the raw materials are increasing and the prices are increasing. But we're not really seeing that with inkjet. We're actually seeing the opposite. The price is slowly, it is decreasing. This is mainly because now the volumes are coming through. Inkjet is, as Agfa will know, is a huge industry, not just for PCBs, but for everything.
Been around in many industries for years.
Exactly, and digital is becoming more prevalent. So the availability of those materials is becoming more available. Price comes down. So we do anticipate the price coming down, whereas we have seen the price going up of traditional solder masks. But that really isn't the big picture. You need to look at the cost of the process from not just the cost of the actual ink itself. It's you're reducing processes, you're reducing energy, you're reducing water consumption, you're reducing staffing levels, all the things which have been covered by ourselves, SUSS, Agfa. So the big picture, actually, it's very cost efficient.
Okay.
And you also use less mask, as Mario rightly pointed out, up to 50% less. So
I would like to rush to a few more questions because otherwise I cannot keep up with what's being asked. So thank you anyway, all of you out there for asking the questions. I think a few questions for Luca. What is the average thickness of the printed layers?
Okay, well, on average thickness, we start immediately with looking at the ink supplier. There is a thickness of solder mask, which is the target thickness. But yeah, looking in the kind of thickness control that inkjet printing delivers, we can very easily give some more freedom into thickness design. There was also, Mariana, in your presentation, you showed some example of a thin solder mask or an increased solder mask thickness, for example, for needs of voltage breakdown. We see electric vehicle coming up in our roads, and these machines need a high voltage, so they will need thicker solder mask.
Yeah.
So 30 micrometer is what is common, but we see, especially with inkjet, the capability of making thicker solder mask to.
Yeah, it's a 3D process.
Exactly.
And what about the minimum line space?
Well,
and the width of a copper track, minimum width.
We give as a spec for our machine of a 75 micrometer line space. We know, because of our work in our lab and the collaboration we have with ink supplier and pre-treatment, that the technology will allow better results and finer lines and finer space in the coming developments.
Yeah. Further questions: how far is the printhead distance from the bottom of the printhead, I would say, to the substrate, and how do you accommodate for bow and twist of the panel?
Okay. Slightly different question. So I will first answer the distance. The distance is 1 millimeter.
Okay. Yeah,
It's 1 millimeter as a parameter, as a recipe parameter. You could vary a little bit from that distance, but that's in inkjet in general. That's a common.
But we have
distance.
sensors to accommodate for the height control, so we're
We-
not going to
yeah,
crash
but-
heads in the panels, right?
There is a light curtain
Yeah.
that will check that the panel is clamped to the table.
Yeah.
And then it comes to bow and twist. Yes, bow and twist is something common in the PCB industry. That's why in our system we accommodate for several vacuum systems. We have a perimeter vacuum to ensure a firm grasp of the edges. We have several zones in the middle of the table with a porous structure that will therefore clamp the system everywhere on the board. So every area of the board is used to clamp. With this porous table, the bias have less influence on this. You might think that at the bias you have less clamping, but because of this porous table, this doesn't.
And you have
happen.
a vacuum tables.
Exactly.
So down. Question came earlier also about if we can support solder mask defined pads and the accuracy that we maintain there, also for like 0.4, 0.5 VGAs.
Yeah. Okay. So there are some nice thing from Inkjet about it. Of course, we can support solder mask defined pads. We can, and this come very well in use from BGA. You might have from a single BGA, you might have branches of copper. So you want to have it. With our machine, the resolution is high enough to create very well-rounded solder mask defined pads on the BGA. The distance of 0.4 millimeter, 0.5 millimeter are very common and very well achievable with the JetXSM. And what we see also is that there is a tendency to go even to smaller pitch and smaller opening diameter. This will be possible. We are printing a liquid. So if we enable our customers with the flow engine, so this tool that control the flow, we will be using physics to create perfect round.
Yes, that's the beauty of the digital process. Yeah.
Exactly.
The ENIC has been approved, and what about AnyPig and EPIC finishes? Or is this a question I should really pass on to you guys?
Yeah, I mean, I can answer that. I mean, we've certainly looked into those finishes. At the moment, we've covered all finishes, final finishes. Some of the newer ones coming through. It's compatible with those processes from our specs.
Yeah.
And I think Mariana is confirming that from
Yes,
the
yes.
Agfa side as well as the
Yes,
Electra
yes.
side as well.
Yeah,
Okay.
some, it's not used so much, some of these finishes, so maybe few further tests will be required, but yeah, from the test we have done, we have not seen any issues.
Okay.
And this targets both the use. So if you have solder mask, you can apply AnyPig, but also the solder mask inkjet is compatible with a bath. So there is also results from leaching tests that ensure that solder mask inkjet is compatible with post-treatment of that type.
Okay. One question I would like to quickly answer so that everyone can see that I try to believe that I know a little bit as well. It's about automation of the system. The system can be automated completely by SUSS MicroTec's own solution, but we also now, especially with some live customers that we have and where we are going to install, we are going to cooperate with third-party automation suppliers from various well-known and well-established European companies. So I hope that that one's answered with it. I see one more question actually, Luca, about how small the solder mask defined pad could be.
Well, we give 150 micrometer as a smallest diameter. What I was mentioning before, so using the physics to create perfect round, we can go well below that. So down to below 100 micrometer. And this is something that it starts to be, as we say, we use physics. And there we need to be in well agreement with the ink. So which ink are we using and which pretreatment is being used. So that's exactly where the flow engine that we presented shines. Because this is not something that you can do it manually. You have to really use calculation power algorithm to make it happen.
Yeah, and I think I could add to that as well, that using the Samba heads from Fuji Dymatics, that they have definitely the smallest nozzle size, picoliter size, and with the 2 picoliter droplet size, actually, it allows a very, very nice and fine edge definition of the product.
Yeah, just a couple of words on the Samba. Small droplet. That's the beauty of a fine definition. Also recirculation. So what Mariana was mentioning before, that there is a great care to create an ink. With the recirculation we have in our system, we take great care that the ink comes at the right formulation, at the right temperature in front of a nozzle when it's jetted. So yeah, that's why this Samba head was a proper choice for ink solder mask.
Yeah. Is there an average expectation of the lifetime of a printhead, which is a question that comes by several times?
I think that the best answer would be to use data. We have had a customer running 2 JetXSM18 for a total of 12 heads for more or less 4.5 years running production. So the tool was working continuously.
Yeah.
And over the span of that time, they changed 5 heads.
Okay.
So we're talking at a very low number. And on top of that, we know that some of his heads were, there was some mishandling. So that's why it was.
Yeah. Well, there was also a question earlier about how would we deal with blocked nozzles, but obviously, as we are here also with technology partners like Agfa and Electra Polymer, I think it's fair to say that there's a lot of development in your joint cooperations to make sure that basically the clogging of the nozzles is almost not occurring. If it does occur, which happens to be, to my recollection, and inevitable with printheads, they will open up again after some time. They won't destroy the nozzles immediately. Is that correct to say?
But I think the remark comes maybe from the experience with legend inks. Now, legend inks are used in much more volume, so you have less, refreshing in the system. And also in the white inks, the pigment is much heavier.
There are particles.
So it's much more difficult, a legend ink, than solder mask.
And lower viscosity.
Yeah, and also a lower consumption, while solder mask would be much higher consumption, much more circulation, much more refreshing of the ink. Yeah. So the lifetime, I expect, will be a lot longer with the inkjet. Solder mask and with a legend ink.
It also probably depends a little bit on the type of head that you're using, because obviously we standard use the Fuji Samba heads, but we also work with the Konica Minolta, different types of heads. So
I mean,
it's really down to.
I mean, just from our experience, we've had heads in our machines for many years now, and we run a lot of different products and a lot of different inks with the same heads, and they're still working fine. So I think that's a validation of the lifetime of a print head, because we are experimenting with products through the heads, and they're still jetting correctly.
The way that SUSS thinking that way is that the ink should do a function. So it should be a solder mask ink. Of course, if a solder mask ink jets well, and if we can make the most out of the Samba with its analog waveform to make a very well jetting drop, that's a good thing. But we prefer to have a very good solder mask that adheres, that is good to be processed, and we take it on us to offer the redundancy within the tool. So we talked about recirculation. That helps to keep all the nozzles continuously refreshed, as well as exploiting this small droplet that is used by the Samba. So there you are building inside your process redundancy. We have been making some easy calculation. If you make a small feature like a line of 75 micron, 20 micrometer high for a millimeter, you go from regular printheads that are with few tens of drop is what you have to make this line.
Mm.
And you go to a sump and you have 500 of this drop to
Yes,
make it. So
obviously.
if you miss some, you don't even
It
notice.
compensates very, very quickly anyway, so you don't. So by the time the nozzle would come alive, you wouldn't even have noticed that it has not been firing correctly. Plus the fact what Peter said, in the Samba had over 2,000 nozzles in one head. So,
Yeah.
Okay. Could you explain again how you got the innovation award? Which really, I must admit, I haven't seen the award itself, and
Well, you
didn't even notice it was on the table. So
here you are.
but the question came again. Who? So
Well,
I'll leave that to you to answer.
Yeah, well, we presented the SM24, so the big brother of the tool we have seen today in the video. And the SM24 was, the way we see it is we learned a lot from the SM18, so the 18 by 24 table. We maximized the quality that we could get out of this system, but we noticed that there was not really a perfect match with manufacturing around the world, with speed and the size being the two most, the bottleneck of this SM18 tool.
Mm-hmm.
So we decided to go for a larger table, and a table which is compatible with multiple substrate sizes to make it easy for manufacturing to have an incredibly fast way to switch between boards,
mm-hmm.
as well as giving options on throughput or on color. So you can have two colors on that system. You might have a green and a red always present, or you can maximize throughput. So I have 16 heads always running with one color, continuously printing. And there you can achieve more than one panel per minute performances.
And the award then?
And that's these all details I just gave were given to the jury, and which was composed by several eminent persons in both the PCB manufacturing, but also in the academic. And it was their decision to.
It was rewarded by the committee during Productronic, huh?
Yes.
Yeah.
Yes.
Okay.
Well,
Well, that
really
should
an
answer
honor
the question.
to get this prize.
We're nearly there. There are a few questions which I believe are not completely related. Which electronic components cannot be mounted on printed circuit boards? I don't think that that's a question that we can answer here as related to solder mask inkjet. So I would kindly skip that one. And another question, is it really there? What does that mean? Yes, I can say as well, we know that we are installing machines, technology has arrived, and it's really out there. I think one big advantage, what you mentioned also about the OEMs, is that they start to realize that it's offering a lot of advantages in cost, in technology, in.
But we have people already using 100% inkjet for solder mask.
Yes.
They have no other process.
Yeah, but it's obviously helping the printed circuit board manufacturers who many times have to go through a long, winding qualification process of new solder mask inks.
Yeah.
So therefore, they would have to keep operational their conventional line if they were to decide to invest in inkjet solder mask technology. But obviously, with big OEMs starting to realize that there's definitely more than a few advantages there, that it could help to speed up the.
And of course, not every end user actually needs to have the approval of their facility as such.
Yeah.
You know, a lot of the times, if you have SM840 approval, that's fine. That's what the solder mask needs to be, and that's a vast majority of customers just need that approval.
Yeah. Okay, I think we've nearly come to the end of our webinar. I see there was a long list of questions, so we might have missed one or two, but definitely if you feel we have missed your question, then please do not hesitate to reach out to the SUSS team. We will be more than happy to answer the questions afterwards. And I think that first of all, I would like to thank you, all your participants from wherever you are, many people. So it was worth the effort. Thank you, Peter. Thank you, Munir, for operating it from the lab in the factory. And thank you, everyone here. Yeah, thank you once again, audience. And
thank you, Andre.
Thank you.
Thank you, Andre.
So Yeah, from Eindhoven, with love. Good night.
Good night.
Bye-bye.
Bye-bye.
Bye bye.